All right, so this is going to be pretty short, section 1-2b, and we will probably start on 1-3, so we'll call it probably 1-2b and 1-3a. It's kind of weird, but that's all right. Okay, we got time to do that. This will not take long at all, this part. Let's see where I want to. I tell you what, I'm just going to start with the example. They give you a little bit of explanation of it, but to tell you the truth, they probably you probably won't really understand that explanation. But the example itself is good enough. Okay, I'll just show you how to do the example. So this is example 5 on that lesson, and it says find the first 3 iterates. Okay, iterations and iterate. I'll tell you. Here, let's just write that down. Find the first 3 iterates, which we're going to call x1, x2, whoops, that's supposed to be a 2, it's supposed to be a comma, and x3 of this function of f of x equals 2x minus 3, with the initial value x, and then watch. See, this is x1, x2, x3, which means they're different numbers, okay? Even though it has an x on it, x1 and x2 are different numbers, x3 is a different number. This number right here, we say it's x naught. You ever hear that word? N-O-U-G-H-T? Kind of like means nothing, 0, okay? Like British people will say that. You know, they'll say, oh, we lost 5-0 or something like that, 5-0. They'll say 5-0, but sometimes they'll say 5-0 as well, okay? So, and here, I'm going to show you what we're going to do here. Okay, so here's what we're going to do. We want to find x1, x2, x3. So that little thing that I kind of left out, I'm kind of doing it right here. So they say that x1 is equal to f of x0. Okay? So if I want to find, this is what I'm trying to find. I'm trying to find x1, and then after that, I'm going to find x2. Then after that, I'm going to find x3. So how do I find x1? Well, it's f of x0. Well, I know what x0 is. What is it? They give it to me. It's 1, right? So what am I going to do? How am I going to find x1? Just take a 1 and put it in for the x, right? Really simple. Simple substitution, right? So you take that x0, whatever it is, you put it in for the first f function. We're going to have 3 f functions. We're going to have f of x, well, we're going to have the x1, x2, x3. Anyway, here we go. So let's plug it in. What do we get? 2 times what? 1, pretty easy, minus 3. 2 minus 3 is negative 1. And so x1, that's our first thing that we want to find. So let's make a little list here. x1 is equal to what? Negative 1. Good. Now what we're going to do, in order to find x2, we're going to go f of, if you start at x0 or x0, what do you think the next one up from that is? x1. So we're going to go f of x1. Everybody see that? Now again, I kind of left that out at the beginning, but this is how you do the iterations. But it's here. It shows up here anyway, so you just be repeating it. So that's how you find x2. How would you find x3? F of what? x2. Okay? Everybody see that? So you just find the next one. Now, in order to find x2, you have to know what x1 is. So you got to do this one first. So what is x1? It's negative 1. So now what are we going to do? Instead of putting a positive 1 in for x, we're going to put in a negative 1 in for x. So it's going to be 2 times negative 1 minus 3. That's negative 2 minus 3. In your head, what's that? Negative 5. Now what do you think we're going to do? This is x2. Let's write that down. make our little list. Okay. And now what do you think we're going to do? In order to find x3, we go f of x2. Well, we just found x2, which is negative 5. So guess what we're going to do? Take that answer and put it into here. Do you see what we're doing? We just start off with that first one, we plug it in, then we get an answer, we take that answer, we plug it back in, you get an answer, you take that one and plug it back in. You can keep doing that as many times as they ask, right? They just ask for the first 3, so we're only doing it 3 times. So 2 times what? Negative 5. Do you see the pattern? Yeah, it's pretty simple. So that's negative 10 minus 3 is negative 13. And we'll just write it down there. So x3 is equal to negative 13. And there you go. That's all there is to it. Pretty basic, isn't it? I mean, you wouldn't have known that word and you wouldn't have known what they were asking you to do at first. But now you see it, what the little the method is to this. And it's actually not that bad. So they start off giving you a first x naught. So you put that in there, you work it out, you get an answer. Take that answer and you plug it back in, right? Then you take that and you get an answer, you take that answer and you plug it back in to the same function, all right? Putting it into that same exact f of x function. What do you think? Pretty easy? Yeah, not bad at all. All right. So that's section 1 too. I think I gave you homework yesterday on it, didn't I? Or I told you what the homework was. Did I? Don't remember. But I'll write it down again. So technically tonight your homework is this. Section 1, 2. You're doing pages 17 and 18. And you're doing numbers 11 to 27, but you're only doing the odds. 11 to 27, and you're only doing the odds. So that is your homework. Everybody good? All right. Now, I am not going to I'm not going to do a new video for the next lesson. I'll just start from here. Everybody okay with that? So that's your homework. Let me get started on the next one. I really doubt we'll finish this one. So, but it's kind of basic stuff. You had this in geometry. You had this in algebra 2. You're going to have it again. But again, this chapter is pretty much just review. So I'll just write it down. So this is section 1-3. I don't know if we'll finish or not. We'll just call it section 1-3. We'll decide at the end. Yeah, but this period is actually, it's 50 minutes long, this period. Usually all the other classes are 40. Am I doing my math right? Because it's 8:50 to 9:40. That's 50 minutes, right?
I think so, yeah.
Yeah. So it's weird. I don't know why they make this one longer. The other ones are all a little shorter because of chapel. I don't know. Anyway. I think it is, isn't it? This class goes from 8:50 to 9:40. That's 50 minutes, right? Am I right? I was looking at it. I'm like, I think I'm doing this right. I think I know how to subtract. So, yeah, that is right. So it's, I don't know, it's kind of weird. We'll see if the bells actually go to that. That's what's on my schedule, and that's what I wrote down. So we'll see. All right, enough of that. So, graphing linear equations. There was a time, probably in Algebra 1, when you did this stuff. You're like, oh man, this is so hard, because I remember everybody complaining about it when we got to geometry, and everybody was saying, oh, I hate that stuff. Y equals mx supposed to be, everybody groans. But you're going to look back, hopefully, at this point in your math career, you're going to look back and you're going to say, oh yeah, that's easy stuff. No big deal, I hope. So let's see. First thing we're going to do is talk about the general form. We got a couple forms we're going to do. And let's just talk about the general form of the equation of a line. So I'll just write general form. I don't know if you remember this, but it might come back to you once you see it. You remember this? AX plus BY plus C equals 0. So that's the general form of the equation of a line. Now, that form, it looks real nice and it looks real pretty. It's not always that practical. It just looks really nice. Now, what must be true, if you remember, what must be true about the A? Can the A be any number in the world? It can't be negative, so it has to be positive, and it has to be a what? Well, actually a whole number. Because if you could say integer, but integers would include negative numbers. So yeah, this would have to be at least a whole number. Okay, you with me on that? What about the other two, the B and the C? They can be negatives, okay, but they have to be an integer. All right, so B and C has to be an integer, which means basically what? You can't have any fractions. Okay, so no fractions, no decimals. This has to be positive. And you could say this. You could say this has to be a positive integer if you wanted to just use the same words. So this has to be a positive integer. These just have to be integers. They could be negative. They could be positive. It doesn't matter with the B and the C. All right, but the first one has to be positive. Everybody with me on that? All righty. We'll get to that in just a second. Let's hit a couple other things. This should be really super basic for you, but we're going to hit it anyway. An ordered pair. All right, so what in the world is an ordered pair? Everybody tell me, what's an ordered pair?
Like X and
X
Y.
and Y, that's right. X and Y. It's in parentheses, comma in between. That's an ordered pair. All right, not going to get into that anymore. We'll just keep it there because you've seen that so many times. It's like second nature to you probably, isn't it? All right, let's do this. All right, since you have X and Y, tell me something about this thing. What do I call this? Okay, it's a graph, it's number lines, but I got a real fancy name for it. Okay, when I have numbers here, yeah, there's a plane. What plane? What? Cartesian plane, very good. Okay, you can call it something else as well. Fancy name is Cartesian plane, okay, or you could call it a rectangular coordinate plane. I'll just put those two words down, okay? I'm not going to go into that too much. They have axes, right? Or an axis, A-X-I-S, that's one axis. This is another axis. Which axis is this one, this horizontal one? That's the x-axis. And which is the vertical one? That's the y-axis, okay? Very good. What's the point right here where they intersect? It's the origin. All right, so I'm just going through this quickly. I don't even have that stuff on my notes, but I think it's good to review it a little bit. And there we go. All right, let's do this. Let's put a line right here and talk about that. So let's say you had a line on that coordinate plane or that Cartesian plane or rectangular coordinate plane, however you want to call it, right there. All right, so it crosses these axes, okay, A-X-E-S is the plural for axis. Everybody remember that? So these two axes. So you have two places where it hits these axes. Okay, you got one that hits right there. What axis is it hitting right there? The x. So we call it the x what? Intercept. Very good. I'll just put INT. If you want to write the whole word out, you can. That's the x-intercept right there. So what are the coordinates of the x-intercept? Like, how would I get to that point? I start at the origin. I go here in the x direction, and then I go where in the y direction? 0. So the x-intercept would be what? X, 0. What about right here, where it hits the y-axis? What do I call that point? Well, how do I get to it? I go 0 on the x, and how far it tells me on the y. So it would be what? What would the coordinates of that y-intercept be? That would be 0, y. All right? So in order to find the x-intercept, if you wanted to find the x-intercept, do you remember this? You set something. What's always 0 on the x-intercept? The y is, okay? So if you wanted to find, I think they're gonna ask you, yeah, on this example, in order to find the x-intercept, we are going to set what? The y equal to 0. So once I set the y equal to 0, then I can find the x-intercept. All right? Same thing with this. If I want to find the y-intercept, what am I going to do? I'm going to set the x equal to 0. Okay? So that's super important. All right, enough of that. Let's do an example. You ready? So we just went through a whole bunch of Algebra 1 lessons and geometry lessons just like that, because you've already seen it before on several occasions. Example 1, all right, it asks you to graph, and they're going to put this into general form. Sometimes they call it standard form, almost called it standard form. It's the same thing. All right, there we go. So if I asked you to find the x-intercept, and I asked you to find the y-intercept, you could do it very simply. What did we say? How do we find the x-intercept? What do we set equal to what? Set the y equal to 0. So we're going to come up here into this form, okay, in this little equation right here. We're going to set y equal to 0, and then we're going to solve for what? Solve for x, and that's my x-intercept, okay? Really simple, all right? So let's do it. Plus, that would help me graph it. Once I find my two intercepts, watch this. If I know my two intercepts, if I know where that is, I just put a point there for the x-intercept. If I know the y-intercept, I put a dot right there where that point is. I connect the two dots, boom, I got my line. See how easy it is to graph? Yeah. So let's do it. So if y is equal to 0, what's that? It's 3y minus 0. I'm not going to write that in there, but that's just 0, isn't it? And then minus 2 equals 0. And what do I get there? Add a 2, divide by 3. What's x? 2/3. And it's kind of weird that it doesn't come out to a whole number, but that's life, okay? We do math so much with like regular numbers, everything comes out nice and even, right? That's not really life, okay? It's just so that we can learn how to do the math. So sometimes it does come out to weird things. Now, where is the actual x-intercept? I'm going to write it as an ordered pair. So what is it? It's 2/3 what? 0. So I'm going to plot that point. I'm going to stick that point on my graph because the whole question says to graph it, okay? So I can't just look at this and say, oh, this is what my graph is. Remember doing the slope-intercept form? We'll do that in a minute. You know, there's my y-intercept, there's my slope, just looking at it, put it on there. This one, you got to do a little math, find the two intercepts, and you're good to go. Now let's find one more point. Let's find the y-intercept. So in order to find the y-intercept, what do? We set x equal to 0, okay? We set the opposite one. If I'm finding the y-intercept, I set the x equal to 0. And now we put it in here. 3 times 0 is 0, and then I got minus y minus 2 equals 0. You can do it a couple ways. Add a 2, divide by negative 1. So what is it? Y equals negative 2. All right, I'll let you work that out. You could probably figure that out yourself. Let's write the ordered pair. So remember, the x is 0, so the first one is 0, and the y is negative 2. So now the graphing part's the easy part. We did all the hard work. Okay, the easy part right now is just to graph the thing. And I'll just do it right here. All right. So on the y, it goes to negative 2. So we'll go to negative 2. And this goes to positive 2/3. I'll tell you what, I'll just put a 1 and a 2. Is that all right? Do I really need to fill in the other ones? Not really, because I just need to know where my y-intercept and x-intercept is. So now I can plot the points. So the first one is 2/3 0. So there's 1. I didn't even need that 2 there, did I? So 2/3 is probably about right there. That's 2/3 0. That's the x-intercept. The y-intercept is 0, negative 2, which is right here. And what do I do to those 2 points? Just connect the dots, right? And there you go. And there's my graph. That's what they want. All right, so it goes through 2/3 on the x-axis, and it goes through -2 on the y-axis. And that's how you graph something if they give it to you in general form, all right, which is kind of nice and easy. All right. Remember what I said just a minute ago? We're going to get into another form. What's the other form? Slope-intercept form, which is, we know it as what? Y equals mx plus b, all right? So we will get to that right now. Let's do a little preview stuff before we actually get into that. Let's just talk about the slope. This will be good just to get us remembering it. Here's basically the definition of slope. I think I wrote it like this at some point. Well, no, that's not the slope. Okay, the slope is the change in y. Do you remember me saying this? The change in y over the change in x. Why did I put that triangle? What's up with that?
Delta.
It's a delta. Very good. It's the Greek letter of the alphabet, delta. All right, and we use that for the change in something. So if I'm going from here to here, that's the change in that distance. I could say delta, whatever the distance is, okay? And that's what this is. It's the change in the y over the change in the x. Or you could look at it as, remember this one? Rise over run. That's very familiar, all right, which is good. It's a good way to remember it. But here's another way. The change in y over the change in x. If I was going to be real specific, I've got y1, I got y2. So what would I do with those two? I would subtract them. Now most books go y2 minus y1. It really doesn't make any difference as long as you subtract them in the same order on the top and the bottom. So if I go y2 minus y1, what would I do for the x? I go x2 minus x1. Or you could subtract the other direction. As long as you subtract them both in the same direction, it's fine, okay? You'll get the same slope. So I could also write it what? y1 minus y2 over x1 minus x2. The biggest problem that I've seen that students have had is forgetting to put the y on top. A lot of times we think, well, x comes before y, so x must be on the top. But that's not rise over run, is it? Rise is going up which axis? The y-axis. The run is going across the x-axis, all right? So you got to remember it's y over x. Everybody understand that? Okay, it's rise over run. So it's y over x. So that's a whole bunch of different ways you could write the slope, all right? That should, again, all be pretty common. I did a little picture for that. I think that's good enough. I think we know about that enough. So let's just move on to this. What we've all been waiting for today, right? The slope-intercept form. Now this is a pretty practical form. Well, it depends. It depends on what they give you, right? If you think this is very practical. That first one, I said it wasn't very practical, but if you're just trying to find the x and y intercepts, then yeah, it is pretty practical, right? You set x equal to 0, set y equal to 0, and so forth. Slope-intercept form is pretty useful because you can just look at it. You could just look at it and basically graph it. So if it's already in the slope-intercept form, you really don't have to do any math at all. Like on that general form, you had to do math, didn't you? You had to make x 0, make y 0, figure out what the other ones were. On this one, you should, if it's in slope-intercept form, you should be able to just look at it and say, okay, I can graph that. Well, I almost forgot. What letter do we use for slope? M. Again, we've talked about this at some other point. I looked this up one time. Why do we use M for the slope? People still kind of disagree. They don't come to full agreement on where the M comes from. Some people think it comes from a Latin word that has something to do with like a mountain, right? You go up a mountain, down a mountain. I like that explanation. Other people say, no, it's from something else, blah, 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 whatever. But who cares, right? We just use M for the slope. So that's what the M is right there, okay? So what is the B in this? So that's the slope. What is the B? It's the y-intercept, that's right. Now, I do know why they use the b, because there's another form that you could probably use that would use the a for the x-intercept and then the b for the y-intercept. Do you understand? So that's why they use b for y-intercept. This would be considered, but this doesn't have an a in it, does it? All right, so, and this a is not the capital A in that general form, so it's a different a. All right, and this b is not the same as the b in the general form. It's a lowercase b, the other were uppercase, all right? But that's why the y-intercept is b, because you would consider a being the x-intercept, all right? I don't know. I always thought that's interesting to figure out, like, why do they use b of all letters? Why do they use b for y-intercept? Isn't that weird? All right, but that's kind of why they do that. All right, let's do an example. I think we're ready for an example on this. We are probably ready from when you walked in the door this morning to do these. All right, we're going to graph all these. Well, all these. I think there's a couple of them. I think there's only two. Yeah, there's only two of them. So let's do this. We're going to graph y equals 3/4 x minus 2. All right? Let me put a little graph here. You should just be able to look at it and plot it and not really have to do any math really whatsoever. We'll go 1, 2, 3, 4. 1, 2, 3, 4. All right, there we go. So the first thing that we graph on here would be where? Where's our starting point? Where are we going to start and put a point? That's the point right there. This is not a point, is it? 3/4. That just tells me how far to rise, how far to run. But this is an actual point right there. That's the y-intercept. So that's what I want to put on here first. So here's the y-axis. It's at -2. Put a point right there at -2. And now we start at that point. Okay, don't start at the origin. Okay, start at that point. And what are we going to do? We are going to rise how many? 3. And we're going to run how many? 4. We're going to rise positive. We're going to run what? Positive to the right. Okay, so rising positive means we go up. Running positive means we go to the right. So we start here, we rise 3, 1, 2, 3. Don't put a dot just yet, just keep your pencil there. And then run 4, which means we go to the right 4 places. 1, 2, 3, 4. Put a point right there. And look, once you get 2 points, then you can make a line, right? So you just connect the 2 dots, just connecting the dots. Did you ever do that when you were a kid? Have a book, connect the dots, and it makes a picture? Anybody do that? Yeah. I remember having a book when I was a little kid, right? Had all these numbers on there, and you just go from 1 to 2 to 3 to 4, and then it makes this picture, and you feel like an artist, I guess. It's the closest I've ever come to being an artist. All right, there it is right there. There's your graph. Super easy. All right, let's do another one. Now this one, well, it's not exactly in general form. I'll just keep that there for a second. But what we're going to do is we're going to take it, we're going to turn it into this form. This was already in that form. What do you need? They're up there too. So let's do it. So we're going to graph this thing. So it's 2x plus y equals 5. They made this really easy. Now, is this right here in general form? Not really, no. Now, if you wanted to, because it doesn't say, no, it does. It says graph using the y-intercept and the slope. So they do tell you specifically they want you to use the slope-intercept form, okay? But I was going to say, if they don't tell you that you have to graph it a certain way, you could have found the x-intercept, y-intercepts, right? Set y equal to 0, set x equal to 0, then plot it. You could have done it that way. That'd still work. But this is a little easier. I got one step, only one little math step to do, and then I can plot my points, all right? So what would that math step be? I want to get y by itself, don't I? See how y is by itself here? So let's get y by itself here. So what do we move over? The 2x. So we move it over here. So we go All right. So we subtracted 2x from both sides. So I'm going to go y equals. Now, a lot of people, if like you're in Algebra 1 at the time, a lot of people would write 5 minus 2x, wouldn't you? But you know a little bit better now, right? If you want to put it in slope-intercept form, we want to put the mx first, then the y-intercept to the end. So what am I going to slide in here? A minus 2x, and then what? Plus 5. Everybody see that? Hey, come on in. Thank you. All right, so yeah, so there we go. So there's our graph right there. I'll tell you what, I already got this graph drawn. So let's just extend it a little bit and put a 5 right there. All right, and let's just put it in a different color. We'll use green. So we're going to go y equals negative 2x plus 5. So we go up to 5. 1, 2, 3, 4, 5. Put a point. The slope is negative 2. It's not written as a fraction like that other one, so really what is this? It's negative 2 over what? Over 1, right? So we start at that point right here. Let me drop it down a little bit. All right, so the slope is negative 2. So I go down 2 and to the what? To the right 1. So that would be a negative slope. If you wanted to, I wouldn't on this, but if you wanted to, you could go up 2, but then you'd have to do what? Go to the left 1. That's right. Okay, so I could go up 2 to the left 1, but look, it still lines up, doesn't it? All right, there's no reason to do that. If you really wanted to, you could do another 2 and 1, right? I could go down 2 and over 1 like this. Because sometimes if your points are like super, super close together, your graph might not be really accurate. So sometimes I like to extend the points a little bit more. If you wanted to, you don't have to. All right, so now I just connect the points. And I got my nice little straight line here, and there we go. All right, and there's your graph of that thing right there. Pretty simple. I know what you're thinking. When are we going to do some real math? I know how to do this stuff already. Aren't you? Is that what you're thinking?
No.
I'm sure you are. Tell you what, we're going to, I'll do one little section, and then we'll quit. And I knew we wouldn't finish. We're almost done, actually. If I really tried to squeeze it in, I might be able to, but I'm not going to. We'll leave that for tomorrow. You feel like what? You feel like what?
I feel like we could all do it.
Oh, now? Yeah, well, I got a couple more things I want to talk about. All right, this will be quick. That red slope right there, what was the sign of that slope, the red one? What was the sign? It's positive 3/4, right? So that's a what? Positive slope. That green one was negative 2. So look at that one. What's it doing? It's going down. See how left to right, this one's climbing up? So that's a positive slope. See the green one? It's from left to right. It's going down. What kind of slope is that? That's negative. I'll tell you what, I won't even draw another one. I'll just draw it right here. So 2 more things and we're done. Okay, super, super simple. Watch. What if I had a slope like this? Or a graph like this? What is the slope of that? I had an exciting story the last couple years. You've probably heard it. I don't know if you remember when I talk about this kind of a slope. Anybody remember that story? Probably not. That's a shame. It was a good story, but I'm not going to go through it all. Do you remember I was rappelling? Did I tell you about the rappelling story when I was in ROTC in college? I was, and I was going down the thing, right? So your feet are up against, right? So your feet are up against it was basically a cliff. It was just straight down. It was like sheer rock. It was all rock. So my feet are like this. I didn't tell you about this one? No. Oh, I've had to. And then you guys weren't listening. It was a good story. So anyway, so the guy's like, let up on the rope a little bit. You got to get more perpendicular, right? I'm a math guy. I'm like, I know what perpendicular is. So I know I was perpendicular. He's like, let it out some more, right? So I'm going, okay. I'm going like this, right? I'm like, and he keeps telling me, let it out some, and of course, what happens? Yeah, boom, I'm going like this. My head is straight down. I mean, there's just big, huge rock boulders at the bottom of this thing. It must be 50, maybe 100 feet high. And I'm straight up and down. My feet are straight up and down. All these people come over the cliff. I see all these faces looking at me. And the guy, this was at VMI, Virginia Military Institute. And so, these guys they're college guys, but they're Rangers. They're Army Rangers. We're like top dudes, you know. I mean, buff, strong guys, you know. And they're yelling at me, don't move, whatever you do, don't move. And I was like, oh, I was so embarrassed. I could see everybody's face look over the cliff at me because the guy's yelling to don't move, right? And I'm like, there's no way I'm going to let this dude come down here. And I wasn't that far. I was only maybe 6 feet or so below him, right? I was like, there's no way I'm going to let this guy rescue me, right? So I kind of start bouncing a little bit. He says, no, don't move. So I start bouncing. I finally get my feet on the rock, right? I get where I'm supposed to, and you hold on to this rope on your back. And when you let up like this, then you start falling. You go like this with the rope to your back, and it stops you. So I just let go, and I was like, boing, 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 like 3 boings, right, down to the bottom. And I was so embarrassed. I wasn't even scared. I was probably more embarrassed than anything. But I tell that story because this was what that looked like. This is what that slope looked like. This is not a slope, is it? Right? And what would be left of me at the bottom? Nothing would be left of me. I would be undefined. They wouldn't be able to tell who I was. Okay, that's why I tell the story. It's a long story. I was pretty high up. I mean, it was kind of scary looking down. It was pretty far down. And anyway, so I tell that dumb story. It's not dumb. It's a cool story. And it's true. It's very true. But they had all these rocks down here at the bottom, and if I would be undefined, they wouldn't be able to tell who I was. So what kind of slope is this? It's not a zero slope. It's an undefined slope. It's undefined. Can't believe you guys don't remember that story.
You never told us it.
I bet you I tell that story every time. Every time I do this thing, I tell that story. Okay. Anyway, there's the story. That was a short version of it, but there you go. All right, so that's an undefined slope. It doesn't exist. I tell people, if you go skiing, right, you could go down a super, super steep slope, but will there ever be? Is there enough double black diamonds or whatever? Is there enough black diamonds to tell what kind of slope this is? No, you would never, ever go to a ski resort and your ski slope is like this, all right? This would not exist. So this doesn't exist. It's undefined or it doesn't exist. It's not zero. Zero exists. It's on a number line. We can add it. We can multiply it, okay? We can't divide by it, but you can take 0 and divide it by something else, all right? But 0 does exist. This slope, the line exists, but the slope does not exist. There is no slope. That's what we would say. No slope. That's different than a 0 slope. What does a 0 slope look like? What is it? Horizontal, right? You guys know horizontal and vertical? A lot of people don't anymore. They think they look at their cameras and it says what? Landscape and portrait, right. So people say that all the time. With photography, I always say shoot horizontally or shoot vertically, right? But now every camera says portrait and landscape, and any editing program always says that all the time. So people nowadays say, oh, shoot a portrait or shoot landscape. I'm old school. Vertical, horizontal. So this is horizontal. What kind of slope does this have? Look, if I rise and run, if I go from here to here, how far do I have to rise to get from here to here? 0, correct? How far do I run? I don't know. As far as they tell me, right? Call it x. What's 0 divided by x? It's 0. So what kind of slope is that blue one? It's 0 slope. I'll put 0. That's different than no slope. Let's do the same thing with this. What if I had a point here and a point here? And I want to find the rise and run. So what's the rise from here to here? No, rise. It'd be the y, wouldn't it? Because you're going up and down. Up and down is the y. So how far would I go? I mean, I could count, but in general, you go y number of places, okay? Now, how far do I have to run to get to here? Look, I rose up to here. How far do I have to run to get to there? 0. What's anything divided by 0? It's undefined, okay? It doesn't exist. Everybody see that? So that's why those slopes are what they are. So again, if you're going up from left to right, it's a positive slope. If you're going down from left to right, it's a negative slope. This is 0, that's no slope. And that's a good stopping point right there. I won't even give you what the homework assignment is. You got it on the RenWeb or the facts, right? You could always look. But tonight, what are we doing tonight? We are doing this right there. Section 1, 2, 11 to 27. All right, that's your homework for tonight. Everybody good?